What's up, guys? This is Mr. Maestas here, and this is lesson 2-4, and I'm talking about related rates, and these are story problems that we see often in calculus. So, a lot of people get scared of related rates, but, you follow a formula, you follow the procedure, and it's basically the same procedure every time. You just got to pick out what you need out of each one here, and I think you can get it, okay? So, related rate story problems are problems that use the idea of finding the rate of change with respect to time. Normally we have lots of variables jumping around, but we're always going to use the with respect to time. So here's a procedure I think works very well. First, draw the figure. See if you can draw it out if you need to. If it's already drawn, great. Now, if it's after you draw it, you should choose the variables and the unknowns that you need for the problem. Important thing here is that write what is given and what you need to find, and make sure you use the dt symbol, okay? The next thing you want to do is write an equation relating the variables that you have. Again, follow this procedure. Don't do any derivatives until after you've set up the equation. Anything that is changing needs to be represented with a variable. Anything that is not changing or constant should be represented with a number. So if you see in your situation here that it stays constant, put a number in it. If it's changing, put a variable. Then differentiate after you've seen if there's any relationship. Now C is important only if you have a formula that has multiple variables. Okay, so if you have a formula that you need to be in one variable that you have to reduce it, then you might see if there's some sort of secondary relationship going on between those quantities, and I'll show you an example of that today. You're going to want to implicitly differentiate both sides again, just like we did implicit differentiation in the last video, and you're going to do that with respect to t now. So you're doing respect to t, that means the x's are going to have that attachment along with them. You're going to, after you do your implicit differentiation, you're going to substitute any number values that you have and solve for that one thing you're looking for. Important here is to write a sentence explaining the meaning of your answer in context. All right, we want to make sure we do this in context. So let's take a look at my first example here. This one is not in context, of course, it's just to kind of get us warmed up. So we have given dx dt is -6, y is 4, and xy is 12. Find dy dt. So we're going to use this relationship here, and we're going to take the derivative implicitly. So we're going to take the derivative of the first, which is dx dt, times y, because we're using the product rule, right? X times y. Then we have x times the derivative of the second, the derivative of y is dy dt, equals the derivative of 12, which is 0. All right, now we see that we don't know what x is. So we have a relationship here that we know what y is, so we're going to plug in y in here. So we're going to have 4x equals 12, x equals 3. Notice I didn't find x until after I did my derivative. Now I'm going to plug in all my things that I know. So I know dx dt is -6. I know y is 4. I know x is 3. I do not know dy dt because that's what I'm solving for. And I set that equal to 0. Alright, so that gives me 3 dy dt equals, this is -24, so I'm going to add it over. And then I'm going to divide by 3, and I'm going to get dy dt is equal to 8. Now, normally in these problems, we're going to have units of measure here, which we will see in our story problem verse. Okay, so in this video, I'm going to do 2 examples, and then I'm going to do 2 more examples in the next video, but I might just crank through and do all 4 examples in this video. We'll see how long it takes me to do that. We're at 5 minutes already, so I don't want to make the video too long. All right, so here's my second example. Go ahead and read it to yourself. You can pause it because I'm going to go right into it after you read it. Okay. So we have a rope here, and the nice thing here is we've already got the picture drawn. So what I'm going to do is I'm going to label some things here. The rope is being pulled in, so the boat's being pulled in. I like to put arrows to tell me which way things are moving. This right here is going to be dz dt. That's what's going to be moving in that direction. This right here is dx dt, and that's the rate at which it's moving in this direction. So the boat's moving in this direction, and the rope is being pulled in, and they're both following these arrows. And these represent the rate. So now I see it's a right triangle, so I pretty much know that I'm going to use the Pythagorean Theorem. So I know that x squared plus 15 squared is equal to z squared. Now there's no secondary relationship going on, so I'm going to go ahead and, let's see what else I have. I know that the boat is 50, okay, so that's already labeled. I know that the dz dt is 30 feet per minute. All right, so that's happening all the time. At what rate is the boat, so I'm looking for dx dt when there's 25 feet, so when z is 25. Okay, so I'll plug that in later. Here's my relationship. I'm going to go and do my derivative now. So 2x dx dt, got to attach that because I'm doing implicit, plus the derivative 15 squared is just 0, that's just a constant. 2z dz dt. dz dt. All right. So now what do I not have? Well, I don't have x. I need to know what x is. So on the side over here, I'm going to do a little bit of math here. I'm going to say x squared plus 15 squared equals 25 squared. Notice I did not do this until after I did my derivative. All right, I don't want to solve for x until after I do my derivative because that's one of the things that I need in here. All right, so then I solve this for x. 25 squared minus 15 squared, that's going to be 4, it's going to give me 20, okay? So now I'm going to plug this guy in here. All right, so I'm going to have 2 times 20. And what do I know about dx dt? I don't. That's what I'm looking for. Equals 2 times z, I knew because that's 25. And dz dt I knew, that was 30. And now I can solve, okay? So I'm just going to divide 40 over. 2 times 25 times 30 over 40. And that gives me 37.5. Now, and that's feet per minute. Now, normally I say you don't have to simplify, but in this case I'm going to talk about what this means in context as my answer, so I'm going to go ahead and write that in. So I'm going to say that when the rope is 25 feet out, the boat is approaching the dock at a rate, use that word in all of your conclusions, a rate of 37.5 feet per minute. I could also say the boat is getting closer to the shore at a rate, or the dock at a rate of 37.5 minutes. But I want to make sure I put that word in rate, okay? Okay, I'm going to stop here because I don't exactly know how long my next video is going to be. So I'm going to go and stop here, and then that way I have enough time for the next two examples, okay? So I'll talk to you guys soon.